How are you? Let me hope you are fine and well doing. Today we are going to learn about set theory, and under this subtopic of sets, of course it is the introduction part. I would like just to give a definition to some terms for you to understand. Without wasting of time, I'll define what a set is. A set is a collection of distinct objects. I've simplified the definition. And also, now when we move to elements, these are now the objects in a set. So after having that concept, I've moved on to come up with an example. For example, something I would like also you people to notice that a set is normally represented in this manner. The set has got its name, and it is also placed in bracket. So the elements are placed in bracket, I mean. So for this, we are having set of numbers because the elements are comprising of numerics. That is 1, 2, 3, 4, 5, 6, 7. So the set A is a set of numbers. Then we've got set B, whereby we are having mangoes, oranges, pineapples. These are set of fruits. Then as we move on, we are going to get types of set. The type of set I've highlighted as number 1 is known as empty sets, or we can refer to them as null sets. They are sets with no elements. So you can find a set like this, but there's no elements inside here. That kind of a set is referred to as empty set, and normally is denoted as we are having the null sign here. So it is normally denoted in that manner. The next type of set I've tried to highlight also, I've tried to check on that is universal sets. When you talk of universal sets, this is a set comprising of all objects under consideration. They are denoted as U. Of course, example, let A be the set of fruits. So we are having this set of fruits here. We've got pineapples, oranges, guavas, and bananas. So the universal set will be the set of fruits. Underline the word, the set of fruits. So this is just but a sample of the fruits that we have in the world, that is. But now when we talk of universal set, now it is the set of all the fruits. Here we're just having a sample of them. So we say the universal set, this is a set comprising of all objects under consideration. For example, in your class we've got students, let's say that the whole class is doing mathematics, and that is a class of 20. So and if at all we sample the girls, let's say girls are 5. So we can sample the girls and say, now if at all the girls are 5 in the class, so we say these girls are doing mathematics, yes. But now when you talk of the universal class, that is now what we refer to as the universal set. Then we move to subsets. Take the sets A and B. A is a subset of B if all the elements in A are contained in B, and it's normally denoted this way. So we underline the word that A is a subset of B if all elements in A are contained in B. So for example, I'm having my set A as having 1, 2, 3, 4, and set B having 1, 2, 3, 4, 5, 6, 7. So that is A is a subset of B because 1, 2, 3, 4 is also the number, there are elements also in B. So when you check, there is 1, 2, 3, 4 here, there is also 1, 2, 3, 4 here. So we talk of now that being A being a subset of B. Then another kind of set or type of set I've talked about is known as we got the ones known as equal sets. So equal sets, we say two sets A and B are equal if they contain the same elements. So you can see here, example 1, we are having A is equals to, that is we are having 1, 2, 3, 4, and B 3, 2, 1, 4. So you can see the rearrangement, though the rearrangement is in B is somehow awkward, that is, but in A is that is. So you can check, despite the fact that the arrangement is awkward, or they are not rhyming, in fact. So despite that fact, but so long as the elements in B are similar to those in A, we say that A is equals to B, so we call them equal sets. We can also talk about here the second example. We are having 1, 2, 3, 4, and here we are having now the cardinality is quite higher, so we are having 3, 2, 2, 1, 4. So you find the same thing is being considered. Here we considered the fact of arrangement, here we are considering the fact of now the cardinality. So when you try to check here, you are going to get that with 3, 2, 2, 1, 4 and 1, 2, 3, 4, the fact remains that the elements here, despite the fact here are more compared to here, is that we are having what is known as equal sets. That is, then number 5, I managed to also check on power sets. These are sets whose elements is a subset of A and is denoted as A. So remember, A is a set, and when we say that this is a set whose elements is a subset of A and is denoted as PA, then it means, as you can check down here, I've provided an example here. We got example, and you can see, let's say A has got 1, 2. So a power set, so we are talking of now, we are going to reduce this A into smaller sets or minor sets. So the first set in this A, there is a possibility we have a null set in it, that is, and we can also have A2, whereby we can also have 1 on its own as a set. A3, we can also pick on 2 on its own and have it as a set. Then A4, we can now assume or use now the whole set in particular. So when you try to now come up with your power set, you place now PA, so you'll have such a thing. You pick this set, this another set, this another set, this another set, and place them into one bracket. Then you'll have, or you'll obtain your that is, we talk of now the power set. Then we are moving on, of course, to then that is cardinality of sets. When you talk of cardinality of sets, these are simply the number of elements in a given set. So you can see I've provided an example. For example, set A. Set A is having 1, 2, 3, 4 elements, and B is having 1, 2, 3, 4, 5. So when you talk of cardinality, normally it's represented or denoted in a modulus form. So when you say the cardinality of set A is 4, that is because you are having 1, 2, 3, 4 elements in it. When you talk of cardinality of B, we say it is 5. That is, if at all you are having 1, 2, 3, 4, 5. So that's what we refer to as cardinality of sets. Let me hope you've enjoyed the lesson. Ensure you subscribe, share with friends, and also, if at all you wish me to tackle anything, we can still communicate and we shall tackle it. Have a blessed day.